Hello, I'm Andrew Liu, and I'm a sophomore at Sturva High School. This project was a collaboration between me, Eric Brown, and our advisor, Professor Wei Liu, from Keene State College. So, have you ever been in a time when you're at a doctor's appointment and they ask you, on a scale of 1 to 10, how much pain you're feeling? It's hard to describe, right? You don't know how to do it in a very specific manner. So, during this project, we aim to make a reliable scale to detect from images so that we can have our own scale of pain without having needing you to talk about it. This will be like a small little device with a camera attached to it so it can sense your emotions, pain 24/7. So as it's doing that, you could possibly not have to worry about it. Practical uses could possibly be for elderly homes and assisted living. 99% of senior homes or elderly homes have reported that they're understaffed, and 97% of assisted living places have reported that they are understaffed. So it's very annoying that there's a lot of people that can be checked after, and especially since people have to sleep, it's hard to determine when they're having pain or not. Plus the additional fact that some people might not be willing to express that they're having pain because they feel bad that you might have to treat them as a bother. So, by creating this device 24/7, we can alert different people whenever someone's feeling pain, and it might be how much. So, to do this, I made a simple GUI design to help deal with this and incorporate some models into it. So we can insert an image into here and it will analyze it to detect different emotions from it. So this is a very basic GUI design. In the future, I plan to incorporate our new model that can detect how much pain you have. Right now, it's only a motion model called DeepFace, and it only really detects motions right now. So, yeah. Now, scouring through the internet for different models that might be useful for detecting pain left me with two major choices that I had: PUI feet and DeepFace, as I used here. So the thing about DeepFace is it relies off of trained data like original photos and different emotions so that I can guess what your new photo might be. But on the other hand, PUI feet, which is also an emotion model, uses action units, technically muscles on your face. So using that, they have little diagrams like this which can show you the different muscles in action on your face. As well as that, they use that data to assume what you might be feeling. This is more of a determinable machine learning so that you can understand how they calculate this. In this case, I have two images, happy and angry. Happy, DeepFace did just fine because it can probably recognize that this is a happy face. On the other hand, PUI feet, which has more accurate things, believe it might have been surprise or happiness. Some of the reasons why this might be is, if you cover this up and look at this by itself, it might actually just look like I'm surprised because the teeth don't get factored in on this little image. So, if we look at the anger, it's pretty standard. You can see that my eyes are frowning and I have different muscles that are contracting. So it's very obviously anger. Now, because I had a data set called MintPain dataset, and it was a lot of data, we wanted to see if we could shorten that down and use only the parts that we needed. So therefore, we have this little mini experiment and research part of it, where we tested if cropping an image down smaller and smaller and smaller will affect the statistics of the different emotions. So through here, we look at happiness, there's very little difference between them, less than 1% even, which means that cropping the photo won't do any damage to the actual results. Then we proceed to here, where we have all the pre-cropped images of the faces. So I picked out three of the most important action units that I found were changing the most here. In this little graph here, we have AU11, which is technically your nasolabial deepener, which is here, it's about the nose. It's only active if you don't have pain. Throughout the entire mean pain data set, they use pain level 0 to pain level 4 to determine how much pain the patient is getting to take the image from. Pain level 0 means no pain, pain level 4 means the max they could administer. So, with the other two details, one of which, AU11, which is the frowning up top, AU4, which is the frowning up top, it progressively has a correlation with pain as it slightly goes up with the pain level. AU23 is the lip tightener, which is down here-ish. It shows how tight the lip is, but it has a very small correlation with pain. The thing is, with these little graphs, we can't tell the exact amount of pain someone might be receiving, but we can tell if they have pain or not. So improvements that we could make to this is, in future, we can make a model good enough so that we can detect pain and then also determine how much pain it is. As far as technology goes right now, we can only really detect if there is pain or not, but not how much. So, that concludes my research project, and in the future, we will work on more ways to finish the GUI and have a more accurate pain level detector. I would like to thank NIH for sponsoring this project.